This is a short video about the mapping exercise that I did with the RCMP near Edmonton, Alberta on July 18, 2024. The problem I wanted to address was trying to find a way to map dispersed remains in an accurate and efficient manner that could be replicated across multiple sites and times. At the time of this exercise, I was hand drawing a sketch map and using a cloth measuring tape. I wanted to know if we could discover if there was an existing technology that could replace what I was doing with my sketch map and measuring tape. However, this technology would also need to work in wooded areas because often dispersed remains were in places where devices could not contact satellites, like wooded areas. In addition to all of this, I really wanted to find a way to use technology to capture additional information about the environment, like topography, vegetation, and water bodies. Because the long-term goal I had in mind was to create a Canadian database of potential information, like topography, vegetation, water bodies, etc., about scavengers and dispersed remains to help search managers plan searches for dispersed remains. I want to find patterns in this database to help searchers increase the rate of discovery of remains and forensic evidence. So, to address the goals and objectives of this exercise, first, we had to establish a baseline. All right, we just set out some bones in here. We set out some in here. There's one. Ooh. There's another in there. And in here. And we got some back in there. We've got some over in here and back in there. I measured all of the bones I'd placed using a cloth measuring tape, and I mapped all the bones and major features of the area on a sketch map. This is the way I currently document the Alberta sites of the Scavenging Study led by Dr. Shari Forbes. I don't use a compass. I usually eyeball the direction of each point. I also usually don't wander too far into the forest. Any topographical features, vegetation changes, or water bodies further than about 50 meters are likely not captured on my sketch map. The sketch map and my measurements would let us know if the devices we were going to use would be capturing data accurately. Next, we brought out the technology.
Here we are.
Oh, measure.
Measure. Okay, continue. So now we're at the offset says 0 for direction, horizontal distance, and vertical distance, all 0, 0, 0, 0. So now do you click on start point? Because it's got an X, Y, and Z in there right now. Okay, now we'll go to an end point. We'll go to the 4 meters. So now we just got to do this for 4 other ones.
Alright. So then I go back here.
So you do it every time?
Okay, and then you move it back. Yeah, so we have to do each point separately.
Oh, yeah, offset it.
Yeah, offset it.
Okay. The GNSS device was able to measure and directionally place each point relative to each other. The accurate direction was something I wasn't currently able to capture with my sketch map. and it seemed that the GNSS was able to provide accurate distances inside of the tree line where we had to offset some of the points. Next, we programmed a drone to capture aerial imagery.
This one is a Mavic 3
Was this a little guy?
Enterprise, specific for mapping.
Really?
So it's got a very good camera on it. It's got a telephoto and a wide angle.
Okay.
Some of the detachments are starting to get a thermal drone, so they'll have infrared on it, but they won't have as good a camera. Ours specifically is meant for mapping.
That would make sense.
Want that one in. Don't need that one in. We'll make it a square.
Yeah, make it easy for the drone there, and because that's just it. We don't know what's involved in the pattern.
No, exactly.
So
look good to you?
yeah.
So then I click on this for the area. That's just going to select my lens. And I want ground sample distance at about 1, which it's going to fly at 122 feet, which that should be above these trees.
Oh, did I
So
not?
that's just the ortho collection. I want oblique collection.
Okay.
So it's going to fly 2. It's going to fly that route, and then it's going to fly that route.
Ah.
Mission is saved. Create area route. Let's start. Max takeoff distance, max altitude, return to home at 300 feet. Change this to 200. And we're good to go. So it's going to take 16 minutes.
Damn. Okay.
It's going to take 1,114 photos.
Okay. Hey, I always say it's better to have too much data than not enough.
1 centimeter per pixel.
I'll take it.
Moving to start point. Point updated. Check map to confirm.
Now we go up.
After the drone was finished, the RCMP members went back to their offices and did some magic work with software. Over 1,000 images were taken with the drone. These images were stitched together to form a composite image. Then the map completed by the GNSS device was placed over the composite image from the drone to provide a map that included the distances and direction of the dispersed remains and information about the environment of the dispersal, like vegetation changes, roads, and areas of human activity. We don't know what influences scavengers to disperse remains the way they do. So we need to collect as much information as possible so we might learn more about what may or may not influence the scavengers and their behavior. All in all, the mapping exercise of July 18th was a success. We found a way to map dispersed remains in an accurate and efficient manner using existing technology. We also found a way to use it in wooded areas where there was little or no satellite receptivity. Many big thanks go to the RCMP members and civilian members that helped with this exercise, including Riley Gukert, Audrey Bernier, Jennifer Barnes, and Crystal Samborski. Thank you to the landowners in the area of the exercise who put up with our vehicles and the drone flying around. And last but not least, thank you to Dr. Shari Forbes for performing the Pan-Canadian Scavenging Study. If you'd like more information on the scavenging study, go to my website, yvonnechorlin.com/scavenging-study.